Example 8 states that at a certain instant, car A is 60 miles north of car B. Car A travels south at a rate of 20 miles per hour while car B travels east at 30 miles per hour. How fast is the distance between them changing 1 hour later? Okay, so car A was 60 miles north of car B. So let me draw that. So I have car A up here, and it's 60 miles, oh, sorry, that's a little wobbly, 60 miles straight north of car B. Now, car B is going east. So car B is going to go this way. And car A is going to go this way, right? A is moving north. Now, the one thing that's not changing, I know it says at a certain instant, but that's the 60. So this 60 right here is never changing. But A is going to move down this, and B is going to move out here. So eventually car B is going to be over here, and car A is going to be going downward along this track. So A is moving this way, B is moving that way. This 60 was at the beginning. So I know that that was 60 feet originally, but matter of fact, maybe let me put A kind of further down. So A is traveling down along that line. So A is starting up here but going down. So A is moving downward. All right, car A travels south at a rate of 20 miles per hour. So I know that dA dt, oh shoot, I ran out of space to write it, dA dt is equal to 20. But it's traveling downward, so it's actually negative 20. dA dt is negative 20 mph. Right? So it's going down. Down is negative. They didn't write the negative in there, but it has to be because it's heading south. And we usually think north is positive, south is negative, etc. All right, so A is zooming along here at 20 miles per hour, going south, so it's negative. A is heading south, but B, meanwhile, is heading east. So B is going off that direction, and it's going off that direction at 30 miles per hour. And it's positive. 30 miles per hour. We usually consider south and west to be negative, north and east to be positive, because, of course, of the compass points of an arrow, right? So this and this, positive, positive, negative, negative, right? That's just how it tends to work for a compass. So that's what we consider. All right, now it wants to know how fast is the distance between them changing at 1 hour later. So the distance between them is right here. I'm going to call it capital D for distance. And what we want to know is what is dd dt. And the only other piece of information they give us is the moment we're trying to look at. So the moment that we want to take a snapshot of is when t is equal to 1 hour. All right, so let's start with, oh, and this is all step 1 right here. I've made a diagram. I've labeled my variables. We're kind of assuming that A is this direction and B is that direction, right? So A, B, D. The distance between A and B, or excuse me, the distance between the points A and B, because there'll be a triangle here. So I'm going to kind of fudge it and say this side right here is A, right? A is that distance there. And this side over here is B, right? So what do we know about that? Well, we know that A squared, because this is a right triangle, A squared plus B squared is equal to D squared. Now, technically, you could use the distance formula, but I'm going to be really honest with you. We almost never do for these problems. We rather use distance squared. Distance squared is easier to work with, so I'm just going to make a little note here. Note, use D squared instead of D. D involves a square root. It'd be the square root of this whole side. And that's just more difficult to take the derivative of because it's easier. I was saying the word of and I wrote it down. All right, so we will frequently do this. We generally don't work with distance because distance has a giant square root in it. So we generally work with distance squared. It's fine because we'll be able to get d dt out of it, which is all we really want. All right, so there's step 2. We have a formula. A squared plus b squared equals d squared, the classic Pythagorean theorem. So now I want to take the derivative of all of this. Oops, sorry, let me write that down. So d over dt, sorry, this is step 3, right here. So I'm going to take the derivative of both sides of this, and that would be a squared plus b squared equals d squared, right? Don't be afraid to write it again. It's not the end of the world. Okay, so to do that, that's going to be 2a dA dt plus 2b dB dt equals 2d dd dt. Now, dd dt is what we're looking for. So this one over here, I don't expect to get anything for. I don't expect to have a value. But I'm going to need values for everything else. Well, luckily, a couple of them were given to us. We know that dA dt is negative 20. We know that dB dt is positive 30. So that's 2 of them. But we're in trouble because we don't have A, B, and D. Right? We know that the moment we want to look at is 1 hour. But what the heck does that mean? Where will everything be? So we need to kind of figure that out. So we're going to go over on the side, right? Work on the side to find A, B, and D at t equals 1 hour, because that's the moment we're considering. All right, so let me go work on this. All right, well, it's a triangle, right? So it's a triangle. Let's think about this. I started off 60 apart, right? So B was here, A was here, and they were 60 apart. And I moved for 1 hour. So since I moved for 1 hour at negative 20, where am I going to end up? 60 take away 20 in that first hour means I'm going to be at 40, right? So A will be 60 take away 20, which is 40. So my 20 got small there. B, well, B starts off due south, and then it goes to the right. It goes east for 1 hour at 30 miles per hour. So that means that B has got to be 30. Sorry, my 3 got weird there. So B equals 30. Because it started here and went that way for 1 hour, and it's going 30 miles per hour, so that's 30. So the hardest one's the A. So it started off 60 north and then moved south for an hour. 60 take away 20 is 40. That's the hardest one. The D over here, well, we could find that with the Pythagorean theorem, right? So we know that A squared plus B squared equals D squared. So we could say 40 squared plus 30 squared is equal to D squared. This is 1600, this is 900, which makes 2500. So D is the square root of 2500, which is 50. Now keep in mind all these are miles, right? Because these are all distances. So this is miles, miles, miles. Now I have all my values because I can use the 40 for A, the 30 for B, and the 50 for D, and I can go substitute them. Oh, I'm sorry. I can go substitute them back up into the formula. And that's what I'm going to do. So over here, for where there was A, I'm going to put 40. Over here for B, I'm going to put 30. And over here for D, I'm going to put 50. There's the work for everything. I can almost get it off on the picture. Okay, so now we just have to look substitute and then solve, and we're done. Okay, so this is 2 times 40 times negative 20 plus 2 times 30 times 30 equals 2 times 50 times dd dt, the thing we're looking for. Okay, 2 times 40 times negative 20. Let's see, that's 80, that's negative 160, or 1600, sorry, negative 1600. And then 90, or 900 times 2 is 1800, equals 100 times dd dt. Right? So this is 200 equals 100 dd dt. And that means that dd dt must be equal to 2, because you would divide both sides by 100. 2. Now distance would be measured, of course, in miles, and time would be measured in hours. So, sorry, I forgot to label, but this is step 4 right here, all of this really, right? So substitution and solving. So that's all step 4, and then down here I'm getting my units, making sure, and then step 6, just kind of double check everything makes sense. And it does.